So we'll start the basic of computational chemistry, and in that case I will be mostly discussing on quantum mechanical calculations. So what is this? So first of all, we have to understand that let us draw a structure of a known molecule called water. So water, you know that this is V shape. It has, according to VSPR theory, it has two lone pairs. This is well known to us. Now if I ask you the same thing, if I replace this hydrogen by lithium, will it adopt a similar geometry? The answer is very difficult to say unless and until, because this is not known, unless and until we do some quantum mechanical calculation and find out the lowest energy structure. And for that we have to first of all we have to identify the equilibrium geometry. Okay, now to do the equilibrium geometry we have to remember that we will do some basic mathematics. But before going to the basic mathematics, let me show you one example. Let us say if we take a diatomic molecule like A2 and this distance is R. So if we use Born-Oppenheimer approximation, and this is the potential energy, I am writing it like PE. So if we use Born-Oppenheimer approximation, if we fix the nuclear positions and then solve the Schrodinger's equation, you will see that when the distance is very very close, they will have high mutual repulsion. When the distance is large, we'll discuss about that, but when the distance is very very small, they will have very very large repulsion between the electron clouds of atom A and electron clouds of atom B. So the potential energy will be very high. Now if we start decreasing the distance or increasing the distance, the potential energy will drop. Now at a point where the potential energy becomes minimum, and again it will start rising. The thing is that at this point the force of attraction is equal to the force of repulsion. That means at this point there will be no net force acting on this molecule. So the amount of attraction will be amount of repulsion, and this point is known as the equilibrium point, and this is nothing but a phenomenon, a theorem called Ahrenfest theorem. Okay, now after this the amount of attraction will decrease, and as a result the energy will increase. Now if you start joining this point, and if you see this point belongs to the lowest potential energy, and the corresponding distance is called the equilibrium distance. So this is how we can calculate the bond length of a diatomic molecule. And similarly, if we go for polyatomic molecule, it will look like a surface like this. It will look like a surface. So that means we have to solve at every point to get the minimum. Now when you say we think about computational chemistry, we have something called a basic mathematics. The basic of all quantum chemical calculation, basic mathematics I am writing. We will use it from, let us say, from our higher secondary days, like if y is a function of x, then dy by dx, if it is equal to 0, we call it a critical point. That means this is a point which belongs to either maximum or minimum. Now to identify the maximum or minimum, what we have to do? We have to do the second derivative. This. If second derivative is greater than 0, we call it minimum. If it is less than 0, we call it maximum. So now we think about the potential energy curve like here. These are the minimum point, these are the maximum point. So we have to think whether our geometry, and remember these are also critical points, because this is connecting between two maximum, this is connecting between two minimum. So these are critical points. So whether we wanted to see whether our molecule is in minimum energy critical point or maximum energy critical point. So for this, in quantum chemical calculation, if you have a molecule like water, like this, it will create a matrix like derivative of energy with respect to nuclear. Suppose this is 1, 2, 3, nuclear coordinate q1 d. I'm just writing the diagonal elements de2, de1, de2 by dq2, and this goes on to du3 by dq3. So this element, these first of all, the software will create a matrix like this, and will try to solve the matrix so that it becomes equal to 0, just like dy by dx equal to 0. So the y is function of energy as a function of coordinate. So this matrix is called gradient matrix. So whenever we use a keyword called OPT, it stands for, I am writing in short form like gradient matrix, and it will, when we write OPT, it will create a gradient matrix and try to bring it to equal to 0 like this. So this is what is called optimization. Now after optimization, we are not sure whether it is minimum or maximum, because optimization is nothing but dy by dx equal to 0, which is a critical point. So this critical point may be minimum or maximum. Then I have to go for second derivative like dy by d2y by dx2. Now this second derivative is almost similar like d2e by dq1, d2e by dq2 square, de3, d2e3 by dq3 square. Now this matrix will have different matrix elements like this one, like this one, like this one, and if this one corresponds to a positive value greater than 0, this one corresponds to a positive value greater than 0, this one corresponds to a positive value greater than 0, we call that this is really a minimum. And how to do the calculation in quantum chemical softwares? We write a keyword like FREQ, which stands for frequency calculation. Now how this frequency is related to this? Now we know that frequency is nothing but 1 by twice pi root over k by mu. So this k is nothing but force constant. If the force constant, that means nu is proportional to the force constant. If force constant is positive, frequency is positive, and this force constant is nothing but related to each of the diagonal elements. So if the diagonal elements are positive, force constant will be positive. If the diagonal elements are negative, force constant will be negative. So for a layman, if we do only optimization, we know that we reached a critical point, but we are not sure whether it is minimum or maximum. But to confirm whether it is minimum or not, we have to do for frequency calculation. If all the frequencies are positive, or in the sense in matrix formation they are real, we call that we achieved at the minimum. So this is the basic of all quantum chemical calculation, because we have to identify the equilibrium geometry, and for equilibrium geometry, optimization plus frequency calculation is compulsory. Otherwise we will end up with a critical point without knowing whether it is maximum or minimum. This frequency will characterize whether it is minimum or maximum. Thank you very much.